Hey guys, go ahead and open your notebook. We'll be writing in your notebook. Open to page 70 and 71. Go ahead and label 70 and 71. 70 and 71 are 8.4 midsegments of triangles. So we're done with triangle centers, but we're going to talk about midsegments. We're going to cut some stuff out of your book. You need to tear out page 398 and hang on maybe more. In case you didn't hear me, that's 398. And maybe another one. I'm just not sure till I turn there myself. Just 398. All right. Get my scissors. We're pretty much cutting most of 398. Okay, so from 398, you need 5 through 6 all cut together. I'm going to go ahead and glue that in on page 71, not 70. So on 71, I'm going to glue in 5 through 7. And then we'll get the rest of it and put it on 71. I mean on 70, sorry. Okay, and then you also need A and B in the box. We're going to put that on page 70. We are putting it down here at the bottom of the page. So we need this space to write. And that's everything we're going to put in. So that's the top half of that page, and I cut out this section because we're going to write in there. Let's put that on the bottom of the page. Okay, I'm going to erase this, and we're going to get started. Talking about what a midsegment is. You can draw over the rest of that page away. You don't need anything. All right, the midsegment. Put something underneath this. It's kind of hard to write on. The midsegment of a triangle is a line segment that connects the midpoints of two sides of the triangle. Okay, we're going to draw a triangle. A, B, C, and the midsegment, I had the midpoint of AB, let's call it D, and the midpoint of BC, and we'll call it E. DE is the midsegment because it's cutting it in half. Now, since it's cutting in half and it's the midsegment, that means this and this are congruent, and this are congruent because it's the midpoint, okay? Something else that's true that we're going to see in the theorem is that they are also parallel. Also, in the theorem, DE, which is the midsegment, is equal to half AC, or AC is equal to 2 times DE. So this is half of this, or this is double this. Okay, and that's what the theorem says down here. So the triangle midsegment theorem says the segment joining the midpoints of two sides of a triangle is parallel to the third side, so it's parallel, and its length is half the length of that side. So let's do an example. Now I'm going to color coordinate these because sometimes it's hard to see exactly what's going on if like all three midsegments are drawn. So in example 2, letter A, it says find UW. So I'm going to highlight UW in green. And I'm going to highlight the third side that goes with that, and that's right across right here. Okay, so the triangle midsegment theorem says that this UW is half of ST. So 1/2 of ST, which is 1/2 of 10.2. So UW is equal to 5.1. In the opposite way, you could find RT because it's twice of UV, so it would have been 11.2. We don't have to find that though, that's not what it's asking. Okay, example B. Find the measure of SVU. I'm going to grab a different color. SVU. Now, what helps us with this is this and this are parallel. Okay, so these two are parallel based on the triangle midsegment theorem. Okay, then it says SVU is congruent to VUW because they are alternate interior angles. Is it interior? Looks like alternate exterior. Alternate interior angles. Alternate interior. So substitute 41 degrees for the measure of angle SVU. Sorry, for the angle what we're finding, VUW. So the measure of SVU is 41 degrees. So you can find some angle measures and you can find side lengths. Now that is frozen, so I probably need to talk about that again. Okay, so sorry the screen froze. Let's recap what I just said with the actual picture showing now. So these are parallel because of the triangle midsegment theorem. Then these two are congruent to each other because they're alternate interior angles, because these two are parallel. Then we take 41 and substitute it for VUW. So we get that SVU is 41 degrees. So sorry that froze. There's another explanation in case you needed it. Okay. Now we're going to talk about what we glued in on page 71. Okay, number 5. How do you know to which side of a triangle a midsegment is parallel? Well, that is the opposite side or the non-touching side. So very specifically, it's the side that it does not touch. Okay. Number 6, I want you to pause the video and try that. It's just like what we did on A and B. Okay, first of all, it says find JL. JL is here, and JL and PN are PN is the midsegment. So JL is going to be double the midsegment, which is PN. So JL is going to be equal to 2 times 39. So JL is equal to 78. That's that first part there. I hope your book's ink isn't like mine. All right, next, PM. PM is here. It's midsegment. It's the midsegment to KL, or sorry, it's opposite KL. So PM is equal to 1/2 of the whole length, which is 95. So PM is 47.5. Okay. And last, we're looking for the measure of angle MLK. MLK is here. Because this is parallel to this, the pinks are parallel, yeah, JMP and MLK are corresponding angles, so they are congruent. That means that MLK is equal to 105 degrees. Make sure it's not frozen. All right, take a minute, pause, and try number 7. Number 7 states, explain why XY is not a midsegment of the triangle. The midsegment of the triangle is the midpoint. X is not the midpoint because these are not 6 and 6 or 5 and 5. Same thing. Y is not the midpoint because this is not the same measurement. So it is not the midpoint because XY, not the midsegment, because XY does not divide these sides in half. Or, more specifically, X is not a midpoint, and neither is Y. Okay, so you are going to now do the assignment that goes along with this. If you need help, you need to let me know.